What's up, guys? I've got a couple of example questions here which are asking us to complete the square to solve two different quadratic equations. We've got one quite simple one and we've got one a little bit more tricky one. So basically what completing the square is a method by which we can go about solving quadratic equations. So let's go straight into it. So completing the square, the first thing we need to do is we need to make sure that this equation here equals 0. So what we have to do is we have to bring all of our terms over here. So what we're going to do is we're going to make this p squared minus 8p plus 21 take 6 is 15, and that has to equal 0. So then what we're going to do is we have to turn the first two terms into a perfect square. Now what that means is we have to get our terms so that when we multiply it out it gives a perfect square. So basically I'll just show you and then you'll probably understand a lot better. A perfect square in this case would be p squared minus 8p plus 16. Now the reason that's a perfect square is because if we half 8p we get 4, and p minus 4 all squared will make this. So then what we have to do is we have to discount the fact we've just added this 16 term. So we're going to get rid of the 16, and then we're going to add back on our 15 again. And that has to equal 0. So what we then do is we factorize this first perfect square. That's why it's called completing the square. So the factorization of this is just going to be p minus 4 all squared. Then what we do is we combine these two terms. So we have the negative 16 plus 15. That's going to minus 1, and that's going to equal 0. So once we're here, we have completed the square. So now we just have to go about solving it. So from here on is just solving. So what we're going to do is we're going to take the 1 across. So we're going to add 1 to both sides. So we're going to have p take 4 all squared is equal to 1. We're going to then take the square root of both sides so we're going to go p minus 4. Now this is where a lot of students come unstuck. This is going to equal the plus or minus square root of 1, which is just equal to plus or minus 1. Then we're going to take the 4 across to the other side by adding 4 to both sides. So we end up having p is equal to 4 plus or minus 1. So our two solutions to this quadratic equation is going to be p4 take 1 is equal to 3, and p is equal to 4 plus 1, which is equal to 5. So there are our two solutions to that first quite simple quadratic equation. So let's go on to the next one, which is a little bit more difficult. So like the one before it, we're going to move everything over to the left hand side so we can get an equals 0 term. So we're going to have 5n squared plus 19n minus, now negative 68 plus 2 is negative 66. And that equals 0. Now, the difference between these two quadratic equations is the coefficient on the n squared term in this case, is 5. Now, it has to always be 1 for this perfect square thing to work. So what we're going to have to do is we're going to have to make this into a 1. Now, the only way we can do that is if we divide both sides by 5. Now what's clever about this is 0 divided by 5 is still 0. And then what we have on this side is we just have n squared plus 19 over 5n minus 66 over 5. And that's going to equal 0. Cool. So what we're going to do now is, like we did in this one, we're going to make a perfect square. So the way we did it in this case is we halved our n term, so in this case it's 19 over 5, and then we squared it. So half of 19 over 5 is going to be 19 over 10. So I'll do this working out over here. So we're going to have to go, to get our perfect square, we're going to have to go 19 over 10 squared, and that's going to be equal to 361 over 100. So that's how we're going to get our c term on the end of our perfect square here. So what we then have is we have this n squared plus 19 over 5n, and then we have this plus 361 over 100 term that we've just added. So like we did in the other one, we have to take it away. And then we put back on our minus 66 over 5 term. Cool. Now, in case, what we have to do now is we have to join these two terms together, so combine our like terms and then factorize this. So if we're going to factorize this first, this is a perfect square. So the way this is going to factorize down is we're going to have n plus 19 over 10 all squared. So there's our perfect square that we could use to get this. We then combine these two terms together, and we'll do a bit of side working out here. So basically what we have here is we have negative 361 over 100, and we have to take away something over 100. Now 5 to get to 100, we have to multiply it by 20. 66 times 20 is 1,320. So if we take these away from each other, we get negative 1,681 over 100. So we'll put that in as this term. So we're going to have minus 1,681 over 100 equals 0. Cool. So like the other one, once we've got to here, that's our perfect square. We've made our perfect square. We've completed the square, so to speak. Now we have to use this completed square to solve the quadratic. So what we've done is we've just changed the form of our initial quadratic equation that you see up the top there. So, like we did in the other one, we get our c term and we take it to the other side. So we're going to have n plus 19 over 10 squared is equal to 1681 over 100. Then what we're going to do is we're going to take the square root of both sides. So we have n plus 19 over 10 is equal to the plus or minus square root of 1681 over 100. And then, so the square root of 1681 is, I checked on my calculator before, is 41. So this is going to be, so if we take this up to here, we have n plus 19 over 10 is equal to 40 plus or minus 41 over 10. So then what we're going to do is we're going to take the 19 over 10 to the other side, and we have n equaling negative 19 over 10 plus or minus 41 over 10. So let's start with the plus. So we have negative 19 over 10 plus 41 over 10. So that's going to be equal to positive 22 over 10, which is equal to 11 over 5. And then we can do the negative 19 over 10 minus 41 over 10 is equal to negative 60 over 10, which is equal to negative 6. So finally, we can say that for this one, n is going to be equal to 11 over 5, or n is going to be equal to negative 6. So I hope this video helped you understand the basic mechanics of completing the square and then solving equations, quadratic equations using the completing the square. I'll be sure to post more of these videos up soon, but until then I hope this helped.